Well, hi, good morning. Thanks so much for joining me here in my shop. Today is July 4th. That's a big day in the United States. So let's see if we can make it a big day in the shop here. So I pretty much replaced, every easy to replace part, capacitors in particular, all capacitors really. And the radio, it did improve in some respects, but it remains kind of with a raspy sound, which you were listening to there. That's a pure sine wave. Should sound much more musical than it does. So I think I can kind of give up the idea that there's some problem with the capacitor in here. There's still some capacitors in here, original ones, but I think they're particularly highly reliable capacitors, so I'm not going to concern myself with those. I'm going to carry on with trying to trace the signal, excuse me, look at it on the oscilloscope and try to see where it goes wrong. And then, I did this once before and I kind of got a little over my head with it, I think, if I remember right. I just had too much going on and kind of abandoned it. Let's continue on with it. So first thing we'll do is we'll look at the output. I'm just trying to make sure I got it right here. The output of the or the input to the output transistors, let's call it that. Now, a little hard to see in the camera, but really this is a series of triangular shaped waves. There's certainly not a sine wave to it. So I'll try to go back a stage. Let's just check right on the volume control itself and make sure the signal I'm putting into it looks nice. It's very weak. So now, again, it's hard to see on the camera, but that's a fine sine wave. Nothing wrong with it whatsoever. From here, the signal heads to the first audio transistor, which are probably the ones back here. Something different about those two connections, and I don't think there should be. I'm going to find the schematic and take a look at it. Well, a little bit of studying didn't pay off very much. So these two transistors that I'm interested in are two T6 transistors, two T6s. I looked on the internet. Mr. Internet kind of let me down a little bit. I could not find a diagram which told me which wire was base, emitter, and collector on the actual transistors. So I'm going to have to figure it out somehow, and I think what I'm going to do, this kind of goes along with signal tracing, so I'm going to follow the signal as it travels from the volume control where I know it's good, and just follow it as best I can all the way through here by tracing right on the circuit board. So the first thing is to try to get to this base. Another hint here are these two resistors, 11 and 10. 11 and 10, 56 and 2200. So I did this capacitor here, which put me, and this one too, which put me right in this area. That's the point I'm going to try to find. It's basically follow this wire through a resistor and capacitor to get there. Follow this wire. I'm going to turn the unit off while we're messing around here. So the yellow wire is the one we want to trace. Yellow wire comes all the way to here. Isn't that a... No, I was going to say it's part of the ground. No, the ground doesn't come this far. It's a separate connection. What's on the other side of it now? What would happen? Okay, on the other side of it. The other side of it's a resistor up to a capacitor. So electrolytic capacitor. A resistor, electrolytic capacitor, and on the other side electrolytic capacitor is the base. The guy. That's the guy we want to test. Let's switch him. Let's get it back on again. Stand this up here. Maybe stand it up this way. Quite. It's going to be very flimsy no matter what I do here. Okay, it'll stay like that for now. Power on, signal in. Okay. So for here, okay, so we'll put this on the ground. You should see it there. Why is it not showing up? Not sure about my ground connection. Yellow wire at the other end. Turn this down, turn this up. I'm not seeing it on my scope. What have I done? What's going on here? What's happened? Okay, kind of knocked off track here. Let's turn it off. What happened there? last time. Nice sine wave showing up there. Okay, now we're going to move out of here. There's something weird going on here. So this scope ground, which is here, which I just put on, you know, it's the same connection as putting it on down here. This makes noise though in the radio. That makes lots of noise. But when I ground it up here, nothing like that happens. Another ground here. I don't know. Why wouldn't the ground from the volume control do that same thing? This is it right here. This is the same wire. One end or the other. One end. Just listen to the radio here. Oop, wrong way. One end grounded on this black wire up here. Didn't seem to make any difference. The other end of the same black wire. You can't see what I'm doing, for crying out loud. Jim, come on. Let's try that again. Black wire running from the volume control. Back here, over to here. Put a ground. There already is a ground on this end from my signal generator. I put a ground on it. From the scope, no difference. I put a ground on here. It's the other end of the same black wire. Why would that be? Presumably this is just a ground connection running all the way around the radio here. But not the black wire. How can that be? How is this possible? Because I'm confused about the black wire. So there's not more than one black wire here. There's only one wire. What's going on there? Is that telling me something? Let's bypass the black wire here. Scope, ground. Either end of this white clip lead. One end, we get that. Other end, we get that. Take this off. Now that's just a wire up to the black wire up here. How do you explain that? I mean, is it even significant? But it certainly is bizarre. How does that happen? Why would the black wire at the volume control seem more grounded? Listen, here it is. That's the ground. That's the. I don't get it at all. Is it part of the picture here for this distortion? I don't think so, but. Okay, let's carry on with the plan. The plan was we'll just ignore the effect, carry on and look at the signal down here. The question is where to ground this. I'm going to ground it where it's less noisy. It does add some noise, doesn't it? Signal's too low to see. So that's something coming from the radio, I imagine. I don't see the audio at all. This is weird. Same thing up here. Look at that. So there's a lot of radio signal here. Find a quiet spot. So despite the noise, well, actually I'm looking, this is the signal just coming to the radio, straight from the signal generator. So despite the radio noise that's impressed on it, making it look a little fuzzy, it looks fine. Of course it looks fine. It's straight from the signal generator. I'm going to have to turn this up a bit. There's so much RF here that I can't really see the audio. So the problem with C14, I'm not killing the RF through there. C14, okay, hold on. C14, 50,000 picofarads. Not one that I changed, but 50,000. Picofarads is 50 nano is 0.05. This is a fairly large capacitor. I'm sure I changed them all. Those size, that size. I'm just getting nowhere here at all because of funny stuff happening. Okay, normally the RF wouldn't really be so visible, I think, after the volume control. Right, because they're trying to snuff it out with this capacitor here. That's a big guy there to let the audio through. Seems to me that's the stuffing, the snuffing. The snuffing occurs there. C14 is very important. Often in a radio, there's a couple of capacitors that are working on RF. Even down in this area, there can be some. Still trying to get rid of it. But this is a very inexpensive early radio, so maybe they didn't care so much. The RF, in the end, can't do anything to the speaker. So let me see now if I can get on this transistor and try to get on the base and emitter. The base is here, the emitter of the collector. Of it and see what we can see. Maybe it's easier to get to the base of this one actually. Because of that. I don't know. Or I just start poking around. I just grab onto, well, if this is the first transistor, then this is the second. I'm just going to grab onto one of these transistor leads here. Ooh. I can't quite see what I'm doing, I think. And the scope is showing a lot of RF. The ticking sound is interference I commonly hear in my shop here. I don't know what it is. It'll tick at a rate like that. The rate will go up and down. Eventually it'll just slowly peter out and stop. I have no idea what it is. Sounds like ignition noise in an engine is what it sounds like. It really sounds like it there. Okay. So when I saw that, was it a good looking sine wave? What was it? I think it was good. Looks a little triangular there to me already. Okay, now let's see if we can get on the other. So that I think is the output of the second transistor in the string here. I'm just going to go at one of these terminals I can get on. There's one. This other transistor, I'm probably on the wrong side of it. I really can't get at other leads easily. A couple capacitors in here. I can see the signal there. Okay, it actually looks. It's so hard to see what it is. It looks triangular already. Sort of shooting random here now. My guess is the RF is really killed by this transformer here. Let's look again at the input side of this transformer. The output of these two transistors. The input side. One of these two legs here. There we are. There we go. Lovely signal. Oh, now this is worth looking at. This is worth studying. First, let me see if I can just make my scope trigger. Well, it's not going to trigger on a varying frequency very well. Looks like a pretty good sine wave, really. The ticking that's in there, you can see these pulses showing up. I don't know what those are, but we can hear them as ticks in the speaker. It's that interference again. So this is what's going into the transformer, which is feeding the base of the two output transistors. So this is actually pretty good. That's actually pretty good. Now I'm going to try to look at the output transistors. I did this before. So we'll look at the input here to one of the output transistors. That's a bad angle here on this. Let's go over here. So what happened there, they just knocked my signal generator lead off. And the signal generator, as you can now tell, is quieting the radio signal. It's absorbing a fair bit of it. You knock it off and the radio signal got a lot louder. I'm trying to suppress the radio actually. A little bit anyway. Okay, we're trying to get on. So this is now one of the inputs, and you can see it's gone loopy. What I mean by that is the wave is no longer a smooth sine wave, it's now a sharp triangular wave. A little hard to see like this. Maybe a little easier if I put a steady signal into it. Now you can see clearly it's just a horrible signal. That's one leg of this transformer. Let me get on the other one. Well, that's nicer. That's a lot nicer. Goodbye all that clicking. Other leg here. I see exactly the same thing. I see a. I think I can stop. I'll cheat it this way. So the change occurs through this transformer. So let me go back on the input side here. Oh, that didn't look very good either. How come it looked so good before? Okay, okay. Glad I went back to check it. So this is the output of the two small transistors producing the drive for the bigger ones. Now you can hear the scope is changing the sound a bit, but I don't think it's responsible for turning the signal into that. Okay, so now we go back to this transistor. Okay, so I'm on one leg of a transistor here. There, see the ticking just stopped? Who knows why? Okay, we're seeing it a little bit. Now that looks like a nice sine wave to me. Sure it is. So we have a nice sine wave on the transistor something. Base emitter collector, I don't know. Okay, so now we're going to go on a different leg of the same transistor. I'm staying away from the middle, the three wires that are coming down. I've done one outside one. I'm doing the other outside one. I'm guessing the one in the middle is the base. Who knows? Okay, I'm on the other leg of this transistor. Oh, look at that. Oh, look at that. Can there be any question? Now, what exactly are we seeing? Signal leaving the transistor or signal arriving at this transistor? I'm going to go on the base here, or the middle one. Oh, son of a gun. You hear a little click there? I haven't seen anything. I don't know what to make of it. Okay. So we've seen the signal reaching this transistor somehow is great. The signal reaching this guy is great. The signal coming out of that guy, that being the transistor there. Well, that doesn't look bad. This looked horrible before. To me, I can see the up is curved this way and the down is curved this way. There is some distortion in here, but it's not a lot. What's this sound like now? Well, it still sounds the same. Why is it I'm doing this over and I'm getting different results? What? Oh my gosh. There's the hint. So in a low volume, it's a perfect sine wave, and as I raise it up, it gets more and more distorted. Just at the low volume, you can't see the distortions. Distortion seems to get worse as I crank up the volume. Now, what can be happening? What can be happening? Let's go on the input side again. This is the just to show you what I'm doing. I'm fooling around with this transformer here. We're looking at the input side or the output side of it. Right now we're on the input side, and you can see the two transistors. This is the one that feeds this guy, and this transistor here feeds that guy. Oh, I'm sorry. This transistor feeds this transistor, which feeds that guy. Right, and we're right on one of the input wires here right now. What do we see? I'm going to do the volume thing. So that effect is already here. So now I'm going to go back to that lovely spot on the transistor. Same effect happening here. Okay, so then I'm going to go further back, right on the wire of the volume control. This is a weak here. It's hard to see. I don't know if we're going to see it. And we got RF in the way. Doesn't seem to get distorted as I crank it up. Let's go at the other end of the yellow wire where it solders on. It's right on this resistor here. I don't think that make a connection. Seems to have, yeah. Okay. Then we go other side of this resistor. Come on out of there. A little hard to see everything that's going on here at the same time. So we're on this little resistor here. We're going up to the other end of it. Same deal. From there it goes to this capacitor, I believe. Should be exactly the same thing. The other end of that capacitor. You can hear the charges on my instrument there. Looks okay. That didn't sound that bad, did it? Come on off of there. So we think we've traced the signal from the volume control part way towards the first transistor. If we go on the first transistor, a leg I can get on. So there's no signal showing up there. So I'm probably on the wrong spot here. The other one, let's just pull this back a bit. Why did that clicking just come and go so suddenly there? Okay, too many things to think about. There it is. Looks great there. Didn't see any funny business. Okay, now in the first transistor, we're going to the second transistor, A leg. What are you doing, scope? What are you doing to me? What happened to my oscilloscope? Something odd happened there. Won't worry about that. So here we are. Looks like a sine wave. Distorted. It has that curve look to it. This is one leg of the transistor, the second transistor. That's definitely distorted there. Did I just see something weird go through the screen there? What's that? What was that weird thing? What is that thing? Okay, I gotta put the better camera on there because this is one of the strangest things I've seen on an oscilloscope. It's going to be out of focus at first till I get it focused. Okay, just take a moment here. What was that? What is that thing? Seems to match exactly the sound, the ticky sound coming out of the radio. That's a pretty strange looking signal. Okay, other than being fun to look at, it's not helping me too much, I don't think. It's just simple interference. It's not part of the picture here. So once again, looking at the sine waves distorted. Okay, trying a different terminal on the same transistor. That's probably the base. Okay, it's connected there. It's not showing a thing, so it's probably not the base. Wow. And this is, so there's 3 legs on this transistor. Here's one. You saw the other one looked exactly the same. And then the last one looks like that. Bad transistor. The input to it could be here. No. Could be here. I have to look at the schematic. Transistor before it. Where did the ticky noise come from now? Just having trouble getting my... Ooh, that wasn't good. Oh, that's not good right at all. Nothing on the scope at all. Hey, scope, what's happened to you? The scope is not responding to anything anymore. What's happened? And where'd the ticky sound just go? Interesting stuff happening over here. Not on the scope. What happened to my scope? My scope is biting the dust. What's happened here? So that's right across the output of my signal generator, which you can certainly hear. What happened to the scope? I'm just gotten so stupid. That's what it is. Stupid. Okay. That's the signal there. Let's change the pitch of this slightly and just... Yeah. That's definitely the signal there. Nice looking sine wave. Okay. You know what? That's not the transistor at all. Did that thing just go ripping by again? Okay. First driver transistor. Yeah, that's it. That looks like a sine wave. It's a little flat, but it's there. Output from that transistor. Input to the next transistor. Output from that transistor. Transistor is bad. Is that where we're going with this? Oh, heavens. Oh my gosh. Come on. Oh my gosh. I gotta turn the set off here. You can't believe what just happened. Yes, you can. There we go. You know, my scope lead has a hook on it. I hooked a bunch of stuff there. At one point, look over this way. Well, where are we at now? Now we really narrowed some stuff down. Signal being input rated the volume control here shows up fine over in this area, but with an awful lot of RF noise. When we get over to here, it looks like the input is okay, but with a lot of RF noise. When we get to here, oh, the curvy triangle has shown up. The output of this transistor is the curvy triangle. The input appears to be sine wave with a lot of RF. Got incorrect biasing on this transistor. These two resistors may be out. We would need to measure the bias voltage here. This has been changed, this capacitor. It's kind of arrangement they have here, like a partial bypass thing, are 16 and 17. What are they worth? 16 is 220, 17 is 5 ohms. That's a 5 ohm resistor there. It's almost nothing. Well, it depends upon the other resistors. So if you've got 5 there, and on 16 you've got 220, I don't know, this is something to stop oscillation, I don't know what it is. There. Now, so how do you get it distorted? How do you get a distortion in it? Usually it's got to be an active device like this. Otherwise, like these things would, in themselves, can only change the level of the signal. They can't change the shape too much. I mean, capacitor can a little bit, but the shape is changing. It's changing. I don't know which lead here. Two of these leads show no signal whatsoever on them. DC voltages on the 3 leads of this transistor, even though I still don't know what the leads are. DC voltages on it. Okay, let's check this out. So I'm going to be looking at this meter here. Okay. So set to DC minus 5 volts full scale. A negative voltage on here relative to the ground will show as a positive upswing on the meter. First leg going the other way. So we've got you know, out of 5 volts, that's just under 1 volt. Okay, another leg. Now we've got 3 volts, and in the middle, so the middle one reads exactly 0.9 volts. And the first lead reads exactly, come on, 0.8 volts. Sounds like a 0.75 drop between those two. That's inconclusive. Inconclusive. Oh, I can't find the pinout for this transistor. I don't know what the pins are. While it's in the circuit, it's a little hard to sort out with an ohm meter. Is the transistor bad? Huh. I gotta stop and think now. It's either the transistor's bad, the components around it are not helping it properly, something funny is going on in the transformer, or something funny with the output transistors is being reflected through the transformer, showing up on this side, making us think the problem is on this side when actually it's the output transistors. I don't know. I'm not sure how to pick my way through this. So I'm going to stop for a little while and ponder the situation. Hey, why don't we listen to this radio for a minute and see just what it sounds like? Hey, that's a good idea. We'll make that the last thing. Okay, let me take off all this interference here. Okay, there's nothing connected. Well, that's pretty interesting. I won't say any more about that. Okay, we'll flip this up. Oh, it's not too happy receiving anything right now. Now I have a booster antenna here, which I'm going to use to try to boost the signal onto the antenna of that radio. I'm just going to put this here. It's about as good as we're going to get here this morning. Same distortion is still there, I'm pretty sure. Okay, I'm not sure what I'm going to do with this. I'm going to stop and ponder the situation. This might be as far as I can get this radio. I have to look and see what transistors I've got in my collection. Do I have any T26s by any wild chance? Okay, so well, thanks a lot for watching to this point. We're not really getting anywhere today, but a little more information. We kind of know where the problems seem to be nested. So thanks a lot for watching.